So anything new you have studied?
We have an exam next week on Monday.
Yes. Oh, yes. So last time is Math B, right? This time is
Yeah.
Math C, specialist. So shall we go through some topic?
Yeah. I was confused about the deriving of vectors.
Victor?
Yeah, I'll show you this
Yeah.
questions.
Yeah, I can. You can share your screen. Yeah. Derive vectors from what? From equations?
It was this question. Question 11.
Yeah.
Sorry.
Yeah. Can I wait for question 11? I can't. Oh, yes, coming. Oh, yes. 11, 12. I can see 12.
Yeah, question 11A.
11.8. Determine the Cartesian equation of the path of the particle. Equation. So you need to find the equation of the path. At the time t, the particle has the position vector, and determine the
Cartesian form.
Yeah, so it's a 3D motion, right, in space, and there's oscillation, and so you need to find the equation in what form? Cartesian equation. Oh, this is a 3D curve, right? So we got a time dependent. So the path. So how can we? In order to get a path, can we just if you do they want to find the equation of x, y, z? Is that
I think so. It's in Cartesian form, which I think is.
So what we can see, x is a 2x sine. Can I participate? Oh, I can't participate.
I'll stop sharing my screen.
Yeah. You tell me the detail. I only see this. I only see this. I only saw this. Wait a moment. Yeah, I saw the vector. Here. Yeah, you can write down. So that is a sine t something.
Yeah, it was.
Can you write the question? The time function. Time function.
Yeah.
Yeah, 2 sine t. Cosine 2t, yes. And plus j. Oh, it's just two-dimensional, isn't it? Oh, it's simple. So you got x. Can we just write the parametrical equation? So x as a function of time is 2 sine t, right?
Yeah.
And y as a function of time is factorial. We can factorize that. It's 2, right? It's just cosine 2t plus 1. That's right?
Yeah.
So in this equation, we have, in both equations, we got t. So we have to, if you can eliminate the t, then we can solve this problem. How can we eliminate this t? We can use Pythagoras theorem.
First, t equals x over 2. I mean, t equals sine of inverse x over 2.
You solve the t. So you just solve the t for x, right? Yeah, yes, that's one thing you can do. So you can from any equation you solve the t, right? That is x divided by 2 at inverse, right?
Yeah.
Oh, that's a good idea. So that is a sine inverse. You can write 2 x over 2, right? That's our third equation. Yep. That's how you can, in this way you can solve, you can eliminate the t. Then that got equation.
Yeah, but can you have an equation like that? Because when you substitute it in, it would be 2 cos 2 sine of inverse x over 2.
Yes, this it looks weird because the period are different. Can you see these two periods are different, and so we cannot get rid of sine function or trigonometry function this way unless we can. Oh well, can we do something? Can we just rewrite a cosine? How do you remember the trigonometry relation for cosine 2t is equal to cosine t squared minus. Do you remember this formula?
No.
No. This is
I
yeah.
think it's in the formula sheet.
Yes, because if this comes from this one, so cosine alpha plus beta equal to cosine alpha cosine beta minus sine alpha. I just had my student asked me the same question yesterday, but in a trigonometry function. Can you see that? So therefore, if this alpha equal to beta, so we got this formula. You see, it's called the double angle formula.
Yeah.
Okay. Another formula is that you can, because we know sine t. Okay. So this so we can rewrite cosine into sine t. We got the identity. We have sine square plus cosine. Do you remember this equal to 1? That is trigonometry. Sorry, this is Pythagoras theorem. So from this one, we can solve the cosines. We can cosine square t into the 1 minus sine square t. You see?
Yeah.
So if we do substitution, so therefore the cosine 2t can be rewritten as the first term is 1 minus sine square t minus the second one is sine. Yeah, that's look. So that would be the expression looks beautiful, not as inverse and inverse, right? So that is 2 sine t squared. Aha, yes. So in this way we can substitute. So basically, so in this way we can get these two formula now. Xt is equal to 2 sine t, right? That will give sine t equal to x divided by 2. And the second equation is for y is equal to, can we rewrite this now? That's the 1 minus 2 sine square t, right?
Yeah.
And that could, yeah, that should be looks like a quadratic equation now. And take 1, right? Plus 1, sorry, plus 1. So I've just rewrite this one. I rewrite this question
why does it become? Oh, right. It's plus 2. Oh wait, no. Yeah, I see.
That's right.
Yeah.
So you got just substitution. So you can substitute sine theta. That become 2 multiply x over 2 squared. Can you see? Plus 1. That's it.
Oh right. Yeah.
You can simplify a little bit. Yes, I think if you use this one, you still get some mark, but not as good as this one.
Yeah.
Good looking. This is. All right. Okay.
Yeah.
Any other question? That's question 1. Yeah, there's a little bit of physics behind it, right? It's
yeah.
Project motion. Do you want to go to your side? You want to go to your?
I'll see if I can do this thing.
Or you can copy it. You can, alternative, you can copy the question onto the whiteboard. Okay, return to whiteboard. Next page. Any other question?
Yeah. So I was just thinking we could work through the questions.
Yes. It's vector. It's a vector question as well.
All of these are like vectors, but
Vector, yeah. Application of vector, right? It's called application of vector.
So this question says 2 ships are observed from station O. Ship A is observed at 1 p.m. and ship B at 2 p.m.
Yeah.
Relative to O, the respective.
It's a relative velocity. Is that relativity? Are you talking relativity?
Yeah, it's relative.
Relative velocity. So you got 2 ships, right? 2 ships is moving in the same direction or not?
They're moving in 2 different directions, and we have to see when they collide.
Oh, okay. I see. Okay, I saw this question before. I just drew a diagram here. So basically, they are moving along the straight line, right? The 2 ships along the straight line. Are the straight line? Yeah, like this one, like 2 ships moving toward direction.
I think so.
So that is ship A, right? Velocity. Position A. A and B. So where is A and B? Can you illustrate that in the diagram? You have 2 points, right? Oh, they can use Cartesian coordinate, yes.
And this is the 2, 6. O, and it's relative to O.
The origin, yes.
It says ship A is observed. Oh, never mind. So this is 2I6J.
That's point A is ship A, right?
And then it's like 11I and B.
Oh, 11.5, yes.
And the times that they're seen are different.
Right. The velocity, are the velocity the same, constant or not?
This is the velocity of A.
It's constant, right? It's constant, yes. So A is, can we just say, if can we just use the arrow to indicate the velocity direction, which is 4, and it is oh, sorry, not this one. This is, so this is 4, 5, something like that, right? That's velocity A. What is velocity B? Looks like velocity is 2, 7. So 2, 7 is go that way. Can you see? 2, 7 go that way. Yes. Ultimately, they were encountered, right? Yeah. So so in this way we know this direction. We know this direction.
The times are different.
Times different.
Yeah, because A is seen by the ship by O at 1 p.m.
Yeah, so the relative velocity, right? The 1 p.m. which at 1 p.m. and what's this? 1 p.m.
Yeah. So this was like this position was seen at 1.
At 1
and
o'clock.
This position was seen at 2. So I think we have to know that it's going to move.
Oh yes, because they are moving along the straight line at different velocity, right?
Yeah, at different times too.
At different velocity. That's right. So basically you have to write the straight line for this. Can you see? How can we write a straight line for this one? So can we just say this is you have to basically build the equation for the straight line, I think. So what you can do is that you can pick up the point. So this is 1 point A is given, right? And next time they will move somewhere here. Do you agree?
Yeah.
Next time we'll move here. And for another boat, When another boat, I use blue colors. They were moved at a certain speed, were moved here. Do you agree?
Mm-hmm.
So basically, you have to build equation, vector equation for these two lines. You see, so this is line 1 or 9A or 9B. It doesn't matter. So this is called 9A, right?
Mm-hmm.
9A. This is 9B. You have used vector to build these two straight line first, and then to solve the intersection.
Yeah.
So this is just a slightly different way to dealing with a geometry problem.
Mm-hmm.
In geometry, they will give you x, y directly. Do you agree?
Yeah.
They give you two straight lines directly, but this time you have to recall how to write a straight line in terms of the vectors. You see?
Mm-hmm.
Let me just show you. So if this is r at time t, right?
Yeah.
We know it's vector. I just write r, and this is r0. Can you see? This is one vector. Can we call this vector? Do you remember how to write the how to build the equation for 9? Use the use different colors. This is it's a white color. Can we just build one first? Can you see?
Mm-hmm.
So there is a simple. So after a certain time, according to our description, after say this is the time, and if from here to count the time 1 o'clock, doesn't matter if we count 1 o'clock. So this time, and that will be this will be the VA, velocity A, multiply the time. Do you agree?
Mm-hmm. Yeah.
That will be after T time. If you count from, oh, this is from 1 p.m. it's in lot of trouble. Another count from 2 p.m., right?
Mm-hmm.
Okay, so it doesn't matter. So basically, the matter is that how can we build this straight line first? You remember how to build the 9 equation? 9A, and build A. So in terms of vectors, this is vector at any time, which can be written as the sum of the A. Can we call this RA? RA multiply and VT, right?
Mm-hmm.
VT. V multiply T.
Yeah.
So that is a straight line for A. Do you remember? Do you remember this in general? Any straight line, you can build the vector equation by. I just gave you a review, so you can build this equation by by using the two vectors. So one vector is from origin here. Another is a vector to this from here to here. Can you see?
Yeah.
So that then you can write the position vector at any time. This is position from this all both from origin. Can you see? So that will give you the vector sum. Now in this case, can we just call this vector is A? This vector is B. Okay. B multiply a constant, a parameter. It could be, in this case, we use T, all right? So in this way, we should be writing the equation right away. So that is R at any time, according to the vector sum, this origin, right? This position vector can be written as A plus BT, right? So what does that mean? So this means that X and Y, can we call this a ship? Can you call this is boat A, right? At any time can be written as matrix form. You see? Yeah. That is what is A? A is 2, 6, right? 2, 6. Why did I write 6, 6? 2, 6, right? 2, 6. So I just rewrite this equation into the matrix form now. Can you see? Yeah. And plus velocity. We know the velocity. What is velocity? At the 1 p.m. 4, right?
Mm-hmm.
That's it. So that is a straight line. You see. In other words, XA equal to 2 plus 5t plus 5t, right?
Mm-hmm.
And YA and YT equal to 6 plus 4t, right?
Yeah.
Of course, we'll fix that. These t have different starting point, so we'll think about that. Okay, and and for the A, for the B, similarly, we can work out. In the same way, we can work out the position boat, the coordinate for the boat B, right?
Mm-hmm.
You know what I'm doing now. So basically, we don't have to use a vector now. We just use matrix form. Can you see? So
Yeah.
the first one is the position. We know that it's 11, 6, right?
Mm-hmm.
However, this time the velocity, we just write the velocity first. Velocity is 6, 7. However, t is t plus 1. We can fix
Isn't
that
the
problem.
velocity? Oh, right. Yeah.
Because that one
No,
is
isn't the velocity 2, 7?
Oh yes. I read this way.
Yeah.
I'm wrong. Okay, yes. Oh yes. You should start physics, but you don't start physics. Now let's just correct that. You can help me. So the velocity is a 2 and a 7, all right?
Mm-hmm.
Can you see I fix this problem now?
Yeah.
The time is use hour, okay? Just tell people time is use hour. The unit for time is hour. It's simple. If you use a second, you have used 3,600 or something.
Yeah.
That's it. 2 equation. We will see when the band occur, either X or Y. So you can just you can use one of them equal. When you don't know if there's a band or not, right?
If there's a what?
Well, the collision.
Yeah.
They ask if they collide with somewhere. Can you see?
No, they just ask. They ask when they collide.
When the kind or one? Oh, they know they will collide, right?
Yeah.
How they are so confident? But if they collide, this is very equal. Can you see? If the collision occurs, this would happen at a certain time. Can you see?
Yeah.
All right. Can you solve this equation to find the time when the collision occurs?
Would we have to put them into one equation and then?
Yes. These condition implied one condition for t to solve the t. You know what I mean? Or you can, doesn't matter. You can also, or you can use YA equal to YB. You can use either equation. You know what I mean? Because this means that because you just remember, we just follow their coordinate, right? So the coordinates, this is XB time t, okay? And when the x and equal to this x, they will collide. Oh, perhaps you have to solve the simultaneous question, right? So that the t will, can you solve one of them at a time?
Yeah.
We don't have space here. Let's give some space at the top. We should solve this on a single page. Yeah, this question is a bit of trick. It's a weird, right? Ask question and okay. Can you use this corner to solve this problem? I think you have enough. Yeah. So that is use x coordinate equal, right? Yeah, t is positive. Yeah. You can check if at this time y also equal. Did you use the first equation? Did you use first condition?
Yeah, I'll check the y as well.
If there's y is work. Certainly we got the time. We can solve the one time. Different, negative.
Yeah. Did I do something wrong here?
For y equal 6, 4 equal to 6, 7 t plus 1. 7, right? 7 plus 7 is 6 plus 7 is 13. Oh, this is 7. This is 7t, right?
Yeah.
Did you write 3? Is that
Oh,
wrong?
because I took the 4 away.
Oh, it's a call. You got another 4. Oh, that's 7. 4 away. Oh, t is negative is impossible, right? So they cannot collide according to this prediction. But we got 1t anyway. X will meet, but y will not.
Yeah.
At this time. What is another thing you have to check? What is the velocity's unit in their question? Meter per second?
Kilometers per second. I mean, kilometers per hour.
Yeah, kilometer per hours. That's right. Yeah, we use hours, so we have no trouble. This shift, the time shift is here. It's reasonable, right?
Yeah.
And so the time when you start to measure the velocity b is the velocity is the important thing is the velocity must be constant, isn't it?
Yeah.
I don't know why they didn't now the y equal. In other words, now alternatively, if this t is different, then we can argue there's no collision because there's no guarantee. Can you read the question? Is that the question whether whether the collision happen or the collision would definitely happen?
I think it says that the collisions will definitely happen. So I think we did something wrong.
Now numerical, right? How about our method? Method is okay. What do you think? So we can work out this straight line for both for the, and we got 2, 6, this coordinate, and the velocity is 5, 4. Another b is 2, 7, and 11, 6. I think we are right. Or you can double check your calculation. 2, 5t. 2, 5t is x, right? Equal to 11 plus 2t, multiply 2t, and 2t, that is that's 13. 11 plus 3 is 13. 2t 3t 11. Yeah, nothing wrong. We got 2 different time, but another thing is negative. Negative is certainly not reasonable.
Do they want us to do it another way, like?
No, you have to check. Do they? Did they say which is at PM? Boat A measured at PM, right?
Yeah.
And boat B is made at 2 PM. Do we have to plus 1 or minus 1 for?
Plus 1, right?
Plus 1 because you're waiting for 1 hour, right?
Yeah. Do we first have to figure out the position, like vector, as in displacement vector, by integrating?
Yes. Integration?
Yeah, because we're doing integration of vectors.
How can you do how do we need to do integration? Do you mean the velocity?
Yeah, do we have to integrate the velocity?
Now this is a constant velocity. For the constant velocity in the same direction, so you just use velocity multiply the you just multiply the velocity and the time. See, because it's a constant movement. if you are talking about a general case, if can you draw something? Are you talking about the actually the particle is moving in like this in any trajectory? Are you talking about this issue, this circumstance?
I think so, yes.
Yeah, if that is the case, then you have to work out the r and multiply the integrate the distance. Or alternatively, what you can do apart from this one, you can use this oh, you have to change direction all the time. No, I don't think so. It's called 9 direction. Have you studied this 9 direction? You have used this formula. You have used this formula. Have you studied this formula?
No.
This is first derivative. Now that is how to find these names, right?
Yeah.
But in our case, you see, we got a straight line. Why should we use integration?
Because it's like this formula where this is velocity, this is displacement.
We got velocity.
And if we assume that this is respective to time, this will get RA equals 5t plus 4tj.
That is what the velocity or r or
that's r.
Is r
as in this r.
No, this is velocity, isn't it? This is velocity. This is r.
If we integrate velocity, then we get displacement.
No, I don't think that is the way to go. The only thing you have double check is, can we just double check if anything wrong? Can we read your question? Can we discuss the question, original question?
I'll show the.
You don't use the integration this time because it's constant velocity.
It's this question. Oh wait, no, not this one. This question.
Number 15.
Mm-hmm.
2 ships observed from the station O. Ship A is observed at 1 p.m. and ship is 2 p.m. relative to O. Yes, both velocity is relative to O. That's fine. The respective position of velocity vector of the ship at this time are given by R, A, B, where the time is measured in hours and velocity in kilometer hour. Okay. We determine the time at which the 2 ships collide. Identify any assumption you have made. Identify any assumption you have made and comment on the effect of this assumption on anyway. Sorry?
I don't think this is important.
No, it is important. You have because you see that they didn't say they were occur. Do you agree?
Mm-hmm.
You see, you have to learn the logic. Every mathematics is logical.
But it said determine the time at which they collide.
That's right.
That means that they will collide, right?
Well, you have assumed the collision occur. You see, that's why I'm asking you whether this the collision will definitely occur is assumption or not. If it occur at the time, the common time, and xy were the 2 xy became identical.
Mm-hmm.
But obviously, you have assumed collision would occur, must occur.
Yeah.
So that is contradiction, because we don't know, because our calculation is contradict to your hypothesis. So we have to reject your hypothesis. Therefore, their collision would never occur. According to our analysis, collision would not occur. Does it make sense? If the collision would occur, the calculated two calculated time must be identical. You go to the answer to see what the answer say. What does the answer say?
Yeah.
You don't have to assume. You can assume, but it's just hypothesis. Does it happen? There's no guarantee. You see different speed, and you. I think it's a good way to the better the way to ask this question is whether the two boats will collide. If so, at what time?
Mm-hmm.
You agree? The better question could be like this: whether collision occur, if occur, what is the time? At what time?
Yeah. It says that it should collide at 3:20 p.m.
3:20. So what is our calculation?
Not 3:20.
How many hours? How many hours? Can you stop? This is the collision would occur, right? At 3 p.m. That's interesting. So our calculation is 11/3.
Which would not be 3 p.m.
Yeah, it'd be a long time. Yeah, the tricky thing is they just measure the boat at different times. You have to, I think we can modify our equation. And I think instead of multiply, alternatively, we can do this. We can multiply t here because we started, can we multiply 1 over here for A?
Mm-hmm.
Not for B. Can you try this way? Do you know what I mean?
Yeah.
Because when after we measure the boat A already moved by 1 hour at the same velocity. Okay, I think that probably probably that would be the case. Can you calculate this? We maybe use this new formula. Can you see? Just how to fix the time. Yeah, I think it's more reasonable. Can you use the same method to work out the x first? Oh, I can't see. Did you use the color or? Oh, hang on. I put block. Oh, yeah, I can see. So use yeah, you can use this modified equation to see the common time.
Cool.
Oh, that's better. That's close to 3 p.m., right?
1 hour and 20 minutes.
That is sweet. That's close to that. How about another one? How about the Y?
Yeah. Oh, no. Yeah.
Oh, the same answer. So the Canadian curve does occur, right?
At 1 hour and 20 minutes,
Yeah,
because 4.5.
Yeah, that's due to this formula. Yeah, the new formula is correct. Okay.
Yeah.
So you see, the trick is how to fix the time, starting time, and this is that's why we can fix that problem. Okay, good. Let's go to other question. Yes, certainly you wouldn't invoke the integral. Okay, it's very terribly difficult to find this integration.
Yeah.
Because the velocity is constant, we don't have use integral. That's why. Okay, any other question?
The next question is the acceleration of a particle at time t.
Yes.
Is given by this.
Can you write it down? A. What is A? Yeah, this is simple. This is Newtonian mechanics. That's why Newton invented calculus to solve this type of question.
Yeah.
Acceleration, yes. 2D, two-dimensional. Okay.
Oh, it's not an I, that should be.
I, K, I, and K. Three-dimensional.
So,
JK, J and K. Okay.
yeah,
J and K.
determine an expression for the position vector at time t.
Yeah.
If initially r t equals
Your
2 I
condition.
plus. Okay.
Yeah, you can try. Yeah, you can try. RT, the velocity equal to. How did you obtain the second equation?
They gave it to us.
Now they must be at a certain time, right? What time? Time 0?
Yeah.
Not any
Yes,
time.
because
At a time 0.
initially.
0. So this is 0. Can you see?
Yeah.
Yeah, that's why I have to. Can you write 0 here? 0 for t. Okay. Fine. That is that allows us to determine two constants. So what is R? Is it final? Is it final?
Yeah.
Final just use a T. Can you see?
Oh, that's the initial. Sorry, that's also initial.
Position and velocity, right? Yes, you have to write this book. Yeah. Can we just help you? Can we just use R0 equal to J? Okay.
Yeah.
All right, you can try. So the two vectors, right? They are vectors. They are vectors.
So first we have to make.
You have used calculus, right? To work it out. This. Sine, yes. Sine. 2 sine after integration.
Yes. Oh, not
sure.
the second one.
Yeah. Can you write the full expression? You actually integrate that original, right? 4 cosine 2t j minus 4 sine 2t. Or I tell you what, alternatively, before you do this, in order to write this unit vector constantly, we can just can we just rewrite R as let me show you. So can we acceleration? Can we? Oh, we can't. This is okay. We can use the integral. Yeah. Okay. So that's your result, right? We double check. So you double check. You got the 4. Why became this original 4 integrated? You divide by 2, right? That's big.
Yeah.
This also integrated by 2. Yes. All right. So this is positive, right? It's positive. Positive. Okay, it's fine. This is velocity, right? That's a velocity. So
I think
we'll have to work out the R first.
Because of this one.
No, we haven't got R yet.
Oh,
this is special. This is special. You can use this condition to determine this constant. Can you see? This must be a constant, right? The integration again. Can you write the formula? You will get the full mark. If you don't write, you probably will not get the full mark. Yes, that is a basic formula. Then use this as your v, because this is your v, right? This is a v.
Yeah.
Sine, cosine, yes. All right. So that is a general condition, right? But here we have to say they have two unknown here. Can we just rewrite this as cosine 2t plus a constant? You see? This is j, right? Oh, we don't know oh, this is vector. We can't write this form. We will compare with the condition to determine the unknown constant. Where should we put the constant? Can we just finish that? Sine 2t plus c2. That's general solution, because we always encounter the constant, right? And fortunately, we didn't change. Oh yes, you are lucky. We didn't. There's still ij, right? Integration didn't change the code. Oh, that's why. Oh, that's where we can compare with our results now. I and k. Oh, I and k. We got a j and k. That's interesting. Do you mean this is I and k? Are you sure it's I and k?
Yeah, that's what it says in the question.
At t equal to 0. Oh, so probably we have put another constant, c2 I, right? There's no guarantee. There's no guarantee. But how come, let's double check. How can they change this is two-dimensional this is two-D motion. How can they involve the k? Can you double check? I'm sure this should be 2jk.
No, it says I.
How come this all of a sudden go to another side? Let's just consider
I think, do we have to make I the constant, make a constant for I?
Yes, let's just consider how could this happen. So this is x, y, z, okay? And the obviously oscillation, you can see the oscillation is the G and the K. See, they got oh yeah, that's possible, but they didn't say the velocity of the I components.
Yeah.
I think this is weird. So this actually, they didn't mention that position for I. Therefore, from physical point of view, this is just the oscillation about I and J. So how can the I come out? So this is so this I think is a B prime.
I think we have to assume that I is a constant. C
I is constant. Yes, yes. C
and then solve that for 2I, and then we know that 2.
Oh, because you if you do the yeah that's reasonable, because that where yeah, because the integration with respect to time, right? Oh yes, you have eventually built the constant over the can we say we assume there's a constant I, right, for the velocity, and also this is true for the position. Yes, that's right, you're right. So after that you have to put another constant, can you see two, right? For I, yes. Maybe this just moving at the same constant along the x. Can you see that is doing this motion? Can you see it's doing this motion?
Yeah.
Like Hennick's motion, yes. You are right.
So now we know that both of these zero constants are equal to 0.
Yeah, I think that should be 0. Yeah, that's must be 0.
And
Because
then,
because that is can be determined by not of cosine. Cosine you have +1. That's trick here. If you see initial condition, this become 1. 1 plus C1. Can you see?
yeah, equals 1 because
equal to 1. So C must equal to 0. Is that right?
yeah.
Okay, that makes sense. Be careful. This is a bit tricky here. That's because cosine at the time 0 is 1.
So if C equals 2, then this is derivative of C1. Therefore, it's 2t. I think.
Yes.
So this would be the formula.
But that direction is I, isn't it? You have to specify the direction is
2ti,
I.
yeah,
2ti. I think that's right. It's good. Solve the 2 questions. Tomorrow? Did you say tomorrow exam time?
Oh, it's on Monday.
Oh, next Monday. All right. Okay.
Yeah.
Let's have a few days to review. Okay. All right. Good luck for your preparation.
Yeah.
I will save that before we last time. I will save that. Okay. Okay.